Hello, class. In this lesson, we're going to learn a different kind of interest, but we're going to kind of lead ourselves in that direction. So let's start by looking at example 1. John deposits $300 into a savings account at 2% simple interest. How much will be in the account after the first year? So let's remember our simple interest formula. It's I equals P R T. So our principal is $300. And then our simple interest rate is 0.02. Now, our time is the first year, so just 1. And since it's in years, we don't need to divide by anything like we would if it were days or months. But it's also multiplying by 1, so you don't have to write that there. So that should give you $6. Now, that's $6 in interest. It asks us how much will be in the account after the first year. Well, that would be our maturity value. That'd be 300 plus 6 is just $306. So now the example that's next, John deposits $300 into a savings account at 2% simple interest. How much will be there after the second year? So we can set this up again. I'll go 300 times 0.02, and you can multiply by 2. Now, you can also think it's simple interest. It's going to earn $6 per year, so it shouldn't be a surprise that we get $12 in interest. And then our total will be $312. But it's nice to show the work sometimes. Okay. But now let's use this as our jumping off point for the next thing we're going to learn. We're going to backtrack for a second. He deposits $300 into a savings account. Again, 2% simple interest. How much will be in the account after the second year if John earns interest on the amount after year 1? So this means we've got a new principal to worry about. Okay. So we're going to use simple interest formula, but instead of $300, how much did he have at the end of year 1? Well, let's go back. That was $306, this total right here. Okay. So we're going to use 306 as our principal, same rate, and we're going to use time equals 1. I know it says second year, but because we have 306, 1 year has already passed. So we get $6.12. So our total is 306 plus $6.12. That would be $312.12. And this is going to be our new interest. This is called compound interest. The fact that we started the new year over with a new principal means we are now looking at compounding the interest multiple times over time. Okay? So this question doesn't really have an answer to it. I'm going to let you think about it. At the moment, compound interest is only earning slightly more interest than simple interest. How long before compound interest is worth it? And we saw that with the totals. With simple interest, after 2 years, it was $312. And with compound interest, the total was $312.12. So only 12 extra cents. So how long before it becomes worth it to have compound interest? Well, this is largely a matter of opinion. We've got how many years will be in the savings account, how much money are we initially putting in, what's the interest rate like. Things like that can ultimately make your decision. So I'm more just going to leave you with that to think about because there's no real correct answer to it. And then so, not really first, but we're going to discuss what this formula looks like. So the formula for compound interest is P times the quantity 1 plus R divided by N to the power of N times T. So some variables, P is still principal, R is still rate, T is still time and in years. Okay. We won't see a whole lot of in months or in days as much anymore. But now we have this new variable N. N is number of times compounded. And this actually has its own set of vocabulary itself. Number of times compounded. So it will say something like we are compounding once per year. Okay. Once per year might say something like annually or yearly. That's n equals 1. So what about n equals 2? What word are you looking for? That'd be semi-annually. Okay. What about n equals 4? That'd be quarterly. N equals 12? You guessed it, that's monthly. And then n equals 52? That'd be weekly. And then, of course, the very famous n equals 365. That'd be daily. Now, I'm going to make this clear. This is our formula for the rest of the unit, okay? However, for the rest of this particular lesson, I'm going to snazz it up a bit. Our principal is only going to be $1, okay? $1. And our rate is going to be 100%. So if we think about 100%, convert it to a decimal, that's just going to be an R of 1. And we're only going to do it over the course of 1 year. So n times 1. And this leaves us with a formula of 1 plus 1 over n to the power of n. Okay, so I'll reiterate. This is our formula for the rest of the unit. This is going to be our formula for the rest of this lesson, and then we'll come back to this tomorrow. Okay. So suppose you deposit $1 into the bank account. We already accounted for that in our formula. So let's rewrite that. 1 plus 1 divided by n to the power of n. $1 into a bank account with 100% interest. How much will you have at the end of 1 year? Okay. So this is just simply n equals 1. So we do 1 plus 1 over 1 to the power of 1. Very unexciting, but you'll see we get $2. We'll have $2 in our account. Okay. So let's go ahead and try the next one. This time, the interest is compounded semi-annually. So if we remember our formula, 1 plus 1 divided by n to the power of n, n will equal 2. So let's set up our formula. 1 plus 1 divided by 2 to the power of 2. Compounded semi-annually means we're splitting the interest rate up into 2 parts over the course of 2 different times in the year. So every 6 months. And you'll see we get an answer of $2.25. Oh, sorry, $2.25. Let me rewrite that. There we go. I had a little pen glitch there. All right. Let's do one more together, and then I want you to try the next couple on your own, and then we'll go over the answers together. So again, write down the formula. 1 plus 1 divided by n to the power of n. So this time, the interest is compounded quarterly. If we look back, that would be n equals 4. You can also think 4 quarters in a dollar. So 1 plus 1 divided by 4, power of 4. This is maybe where we want a calculator. We get 2.44, so $2.44. Okay. So go ahead, try the next one, which is monthly, after that, which is weekly, and then after that, which is daily. Go ahead, try that, pause the video, and come back and check your answers. All right, so if you compound something monthly, that would be an n equals 12, and you get $2.61. So you can start to see the amount is still increasing, but the amount that it is increasing by is starting to lessen. With weekly, we have n equals 52, and we get $2.69. And then with compounded daily, we get n equals 365, which is $2.71 and a little bit extra left over, which I suspiciously wrote for a reason. So let's give it hourly a try. There's 8,760 hours in a year. How do you get that? Well, you got 365 days a year, 24 hours in each day. That gets you that amount. So we have 1 plus 1 divided by 8,760 to the power of 8,760. Let's go ahead and type that in. 1 plus 1 divided by 8,760 to the power of 8,760. We get $2. Oh, dang it, I did it again. Let me go ahead and erase that. There we go. We got $2.71. So the raw principal amount did not go up by much. But then I got 8127 as a leftover decimal. And then finally, we'll compound it minutely, which is not in here for any reason other than I wanted to use the word minutely, which probably isn't a word at all. But setting up the problem, that'd be 1 divided by 1 plus 1 divided by 525,600 to the power of 525,600. So go ahead and type that into your calculator. 1 divided by 525,600 to the power of 525,600. And that gets us 2.71827, but not rounded this time. Before it was 2.669. So let's summarize our results. Well, actually, I'm not going to do this. I want to see if you can discover what the point of this last exercise was. It is a natural consequence of compounding interest. I will tell you that one of the purposes behind it was so that we could get a formula. If we increasingly compound it by more and more, so go by second, go by the microsecond, the nanosecond, and so forth and so on, you will get a different formula out of it. But I'm not going to reveal that to you. See what the significance of, when I went through these problems, I was writing them normal dollars and cents. And then we got to 2.71. See if you can figure out the significance of that number, why I started expanding the decimal. Okay. I will give you a hint. The answer is in the room somewhere. Okay. And thanks for watching.